So, hello everyone, I'm Judy Ambataria. For this video, we will tackle section 11.8 to 11.11. So, what is a power series? It is a series with the form of sum 0 to infinity of a sub n times x to the n is what we call power series. So, a sub n, each term has a coefficient, and x to the n, as each term has a whole number and whole number power of a variable. So, example, so a sub 0 is basically the constant term, but that's the coefficient for the x0 term, and x sub 1 is the coefficient of x term, and x sub 2 for the x squared term, and x sub 3 for the x cubed term, and so on. So, for example, so here's an example of basic looking power series. So, 1 plus x squared plus x cubed plus x to the 4th power, and so on. So, all of the coefficients are the same in this case. So, in summation notation, we will say from 0 to infinity, just have x to those power are all integers, and in this case, it's certainly the coefficient are all equal 1 for each term. So, center of a power series. So, center of power series is a very important because power series will always converge at its center. So this is the power series centered at x equals to 0. And if we're looking for a different type of a power series, so the sum from 0 to infinity of a sub n and a quantity of x minus c constant to the n is a power series that's centered at x equals to c. So, determine the radius and interval of a converter. So, we need to use the ratio test. So, what if we use the ratio test that the limit as n goes to infinity of u sub n plus 1 over u sub n. So, then we get 0. So, what does that mean? So, if the ratio test gives you 0, then it means that the series is a converge for all x values. So, the radius of convergence is equals to r infinity. And the interval of a convergence is negative infinity to infinity. So, then, what if we do not get 0? So, we get infinity instead of 0. So, in order for a series to converge, the ratio test have to give you an answer that less than 1. So, if it is greater than 1, or it's infinity, it means that it's diverges for all x values, except for the particular x value. It will only converge when x equals to c. Let us see. So we're gonna get a limit with some expression of n times 0. N times 0. So the whole limit will equal to 0. So according to the ratio test, it is less than 1. It's gonna converge for that point. But for everywhere else of all other x that is not equal to c, we're gonna get infinity, and so the series will be diverged for all of other x values. So, but for this particular x value, where x equals to c, it is going to converge at the radius of a convergence is equals to 0. And the interval of a convergence is only the number of the interval. So it is just x equals to c. Example c. So for the third one, if we use the ratio test, we're gonna get the expression in terms of x. Typically, it's going to look something like this. 1 over r, so the absolute value of x minus c, which is less than 1. So usually in this format, and once you get to this point, we will multiply both sides by r. So this expression will going to multiply r to this expression. So then we get absolute value of x minus c less than r. So whatever your number you see at this point, and that is your radius of a convergence. So let's try an example. So sum of n factorial times 2x minus 1 raised to n. So we'll use the ratio test. So limit n approach to infinity. So u to the n plus 1, that's going to be n plus 1 factorial times 2x minus 1 raised to n plus 1 divided by n factorial times 2x minus 1 raised to n. So this is the u sub n plus 1, and this is the original u sub n. So now we will simplify. So limit n approach to infinity. So n plus 1 factorial, we can write that as n plus 1 of n factorial times 2x minus 1 raised to n, and 2x minus 1 is to 1 over n factorial of 2x minus 1 raised to n. So we can cancel 2x minus 1 and n factor. So now we have a, can write this as an approach to infinity of n plus 1 2x minus 1. So what happened when n goes to infinity and n plus 1 also goes to infinity? Infinity times 2x minus 1. So how can we find the power series centered at, and what is our c value? So we need to set the inside equals to 0 inside. So 2x minus 1 is equal to 0. So 2x. So x equals to 1/2, or c is equals to 1/2. So if x is anything but 1/2, it's going to diverge. So let's say x equals to 5. So if we plug in it, so 2 times 5 minus 1 is equals to 9. So 2x is 1. So right here is 5. So this will equals to 9. So 9 times infinity is infinity. So whenever x say, if x does not equals to 1/2, so infinity times any kind of value is gonna be infinity, and so the series is going to diverge whenever x is anything but 1/2. So what happened when x is 1/2? So well, if you plug in 1/2 into this expression, so we know we got 0 to 2 times 1/2 minus 1. So it will be 0. Let's try to plug in. So 2 times 1/2 minus 1. So this will be equals to 0. And so 0 times n is 0. So thus the whole limit is going to go to 0. So which means that the power series converges. So anytime we get the infinity as a result, it's only gonna converges when x equals to 0. So that is where the power series is centered. And so for this problem, the radius of converge so here, so the radius converge is equals to 0, because there's only one number where the series converges one x value. So the interval of the convergence is equals to x equals to c, or which is 1/2. So it depends on where the power series is centered on. So let's have another example. So it's n equals 1 negative 1 raised to n times x raised to n over n raised to 2. So first, we need to apply the ratio test. So limit n reach infinity